Hey everyone, this is probably take 76 for this video. It's about partitioning, and the reason why it's taking me so many times is because it's such a complex topic. The idea behind partitioning is very simple, but it's very difficult for our students to do. So I'm really going to try and show you many different things in this video, but at the end of it, if you have any questions, please feel free to ask by email or in the comments, and I'll do my best to respond. So partitioning. Partitioning is breaking numbers into parts. In fact, I show the word part in the word partitioning to all my students. So when they see this, if they remember to see the word part, they'll hopefully remember to break it into parts. So normally I'd get students to start out with blocks or any type of counter, and then I'd have them have a full number here. Right here we have 10, and then I just get them to break it into parts. I always start out with saying it's magic, and to watch, it's magically, now I partitioned it. And I always get them to label the parts too after a while. 4 and 6, and the whole thing was 10. After many times of breaking it into parts with blocks or counters, I then get them to label it on a part whole mat, and I would actually get them to use the counters themselves on a part whole mat so they can actually use their hands and partition numbers. Then eventually I'd get them to do it and label the part whole mat. So if we did this one and put it on the part whole mat, one part was 6, the other part was 4, and the whole thing is 10. So that's how you can use part whole mats. They really help, and they can be done multiple different ways. Another way to do it a lot of people do it like this, where this is the whole, here's a part, and then they would have the whole number up here and label the parts here, 6 and 4. Now you can do it in many different parts. However, just because you have more parts doesn't mean it's a better partition. So if we were partitioning a large number like 99, I do not expect my students to have 99 parts of 1 each. That's not very practical, and it's not necessarily better than any other partition. So speaking of the number 99, eventually we move on and using numbers to partition or base 10 blocks. So if I represented this with base 10 blocks, I would have 10, 20, 30, 40, 50, 60, 70, 80, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99. So I represented 99. Now I have to partition it. So again, I say it's magic, and I show my parts very clearly, and I label my parts. So over here it's 10, 20, 30, 40, 50, 10, 20, 30, 40, and then there's 9 here, so it's 49. And those are my parts, and I'd get them to label it on a part whole mat. So 99 is the whole thing. My one part was 50 and my other part was 49. Now in the classroom, we try and get students to partition as many ways as we can in a certain time. We want lots of different partitions. It really helps out the students. One really popular partition, and I accept it at first, is something like this. If we have 156, a lot of students will partition it with 155 plus 1. At first I'll accept that, but after a few days I'm going to say that's too easy for you now, give me something more challenging, show me some more. And then they'll start giving stuff like expanded form, like 100 plus 50 plus 6. That's a great partition. They may give 150 plus 6, also a great partition, or any other way like that to represent or to partition these numbers multiple ways. I hope this video helped. I tried to keep it quick and simple for you. However, if you have any questions, please feel free to ask. Thank you and have a great day.